Hi everyone, I am Dr. K. Kritika, Associate Professor, Department of Mathematics, K.S.Rangasamy College of Technology. I am going to explain gradient, divergence and curl from vector calculus. So before we enter into this, we should know the operator delta. It is called the vector differential operator. Its expansion is I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z, where I vector, j vector, k vector are called unit vectors along the three axes x, y and z. Then delta square is delta dot delta. It is called the Laplacian operator. So the first one is gradient. Actually, it is another name is slope of a scalar point function. Its notation is del phi or grade phi. So its formula is I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. So here some examples related to this gradient. So the first one is if phi is equal to x square plus y minus z minus 1. So using this we are going to find grade phi, but here one particular point is given. So the first we are going to find del phi. So I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z of the given scalar point function phi. So in the first term we differentiate partially with respect to x. It means we consider y and z are constant. In the second term with respect to y, so we consider x and z are constant. In the third term dou by dou z, it means we differentiate only with respect to x. It means x and y are constant. The final term is I vector 2x plus j vector 1 plus k vector minus 1. So after this, we substitute, we replace x by 1, y by 0 and z by 0. The final answer is 2y vector plus j vector minus k vector. The second problem is also grade phi. If the scalar point function is x, y, z at 1, 1, 1, we apply the same procedure. The final answer is I vector plus j vector plus k vector. So next we move to directional derivative. So its formula is, so here the directional derivative of a scalar point function in the direction a vector is del phi dot a vector by modulus a vector. Then the maximum directional derivative is modulus del phi. The unit normal vector to the, actually this a vector by modulus a vector is a unit normal vector to the direction. But here unit normal vector to the surface is del phi by modulus del phi. The first problem is find the directional derivative of phi. Actually this phi is a scalar point function in the direction. It means 2i vector minus j vector minus 2k is denoted as a vector. Then one particular point is given. So the first one, given scalar point function phi is equal to x square yz plus 4x z square. Then the vector that is in the direction a vector is 2i vector minus j vector minus 2k vector. So next step we are going to find this modulus a vector. It means root of 2 square is 4. Actually minus 1 square is 4. The coefficient of k is minus 2. So minus 2 whole square is plus 4. So in this way we are going to find modulus a vector. So answer is 3. So what is the directional derivative formula? Del phi dot a vector by modulus a vector. So first we are going to find del phi. So as we should in the first example already we discussed gradient phi. So this del phi is called the gradient phi. The answer is this. So here one particular point is given. So after we finding grade phi, del phi at the point answer is 8i vector minus j vector minus 10k vector. So in the next step directional derivative is del phi dot n cap. Actually n cap is a vector by modulus a vector. We substitute all the results. So in the numerator is a dot product. So I vector is 1, j vector dot j vector is 1, k vector dot k vector is 1. So the final answer is 37 by 3. So here some problems related to directional derivatives are here. So these are the practice problems. So next we move to normal derivative. So this normal derivative, another name of this is called greatest rate of increase or maximum directional derivative. Its notation is modulus del phi. That means first we are going to find grade phi, then after that we taking modulus. So it is called the normal derivative. So here one example is given. Find the normal derivative of phi. Actually this is a scalar point function. One particular point is given. Here the question is normal derivative. So first in the solution, first we are going to write the given function phi. Then after that we are going to find grade phi, that is delta phi. So del phi answer is I vector y plus z plus j vector x plus z plus k vector x plus y. After we finding this grade phi, del phi at some particular point is minus 1, 1, 1. So here we replacing x by minus 1, y by 1, z by 1. So the answer is 2i vector plus 0j vector plus 0k vector. So here the question is normal derivative. So normal derivative means just we are taking a modulus. So modulus del phi. So modulus del phi means square root of the square of coefficient of I vector. It means 4 plus the coefficient of j vector 0, so 0 square, plus the coefficient of k vector is 0, so 0 square. Answer is root 4. Answer is 2. The next one is, what is the greatest rate of increase of phi? So I think the greatest rate of increase and normal derivative both are same. Both have the same formulas. So given phi is equal to xyz square, the next step as usual we find grade phi, that is del phi. The answer is I vector yz square plus etc. Then after that here one particular point is given, that is 1, 0, 3. So we replacing x by 1, y by 0 and z by 3. So the answer is I vector 0 plus 9j vector plus 0k vector. So after that modulus del phi, which is equal to 9. So which is called the greatest rate of increase. The next we move to unit normal vector. So the unit normal vector, there are two types of unit normal vector. One with respect to direction, another one with respect to the surface. So here actually this is called the with respect to surface, unit normal vector to the surface, because phi is the surface. It means another name is scalar point function. So n cap is equal to del phi by modulus del phi. So the first example is, find unit normal vector to the surface x square minus y square plus z is equal to 2 at the point. So first we write the given scalar point function, or we say that it is a surface. So which is equal to x square minus y square plus z minus 2. The next we find del phi. It is a grade phi. So the final answer is I vector 2x plus j vector minus 2y plus k vector, that is a 1 into k vector. So after finding this, just we replacing x by 1, y by minus 1 and z by 2, we getting this. But here the question is unit normal vector. So n cap is equal to del phi by modulus del phi. So we are substituting this del phi by modulus del phi. Model means already we explained root of 4 plus 4 plus 1. So which is equal to 2i vector plus 2j vector plus k vector by 3. So this is another problem for practice. So the next topic is a very important topic, angle between two surfaces. So cos theta is equal to del phi 1 dot del phi 2 by modulus del phi 1 into modulus del phi 2. So here phi 1 is called the first surface, phi 2 is another surface. So here the example is, find the angle between the surfaces. Z is equal to x square plus y square minus 3 and x square plus y square plus z square is equal to 9 at some particular point. So first we are going to write the given two surfaces. The first surface is, we take it as phi 1 and second surface is phi 2. We know that the gradient or grade phi del phi formula. So now we are going to find the same gradient for this surface and the second surface. So that is denoted by del phi 1 and del phi 2. So automatically after finding this del phi 1 and del phi 2, we substitute just the points 2 minus 1, 2. So then after that modulus del phi 1. We are going to find modulus del phi 1, modulus del phi 2. We are substituting all these formulas in the final formula. It means the angle between two surfaces. It is cos theta. The answer is minus 8 by 3 square root of 21. So what is theta? Cos inverse of minus 8 by 3 square root of 21. So here another example is given for practice. So the next important topic is divergence and curl. So what is divergence? So we explained, I explained gradient phi, that is del phi. But here this divergence of actually gradient one is for a scalar function, but divergence is for a vector point function. So here del dot f vector, which is equal to I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z dot f vector. So here the given function is a vector point function. We are going to find the divergence only for the vector point function. So it is a dot product. So the answer is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Similarly, curl is also for finding a vector point function. So it is a cross product. Divergence is a dot product. Curl is a cross product. So cross product is always, we write determinant form. I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. Then f1 is the coefficient of dou by dou x term, is the I vector term. f2 is the coefficient of j vector. f3 is the coefficient of k vector. After we expanding this 3 by 3 determinant, we getting this. So here there are important two notes. The first one is divergent effector is a scalar quantity. Then a curl effector is a vector quantity. The next important topic is a solenoidal. If the divergence is equal to 0, it means delta dot effector is equal to 0 means then effector is called the solenoidal. Then del cross effector is equal to 0. It means curl effector 0 means it is called the irrotational. The given vector is called the irrotational. So the next example is here one vector function is given. Using this, we are going to find divergence effector and curl of effector, or its notation is find del dot effector and del cross effector, both are same. First, we write the given f function, that is vector function f vector, then del dot f. So we know the expansion of this del. So it is here dot the given f function, given a vector point function. So here both dot product. So when we are applying dot product, I vector is 1, j vector dot j vector is 1, k vector dot k vector is 1. But I vector dot j vector is 0. So unlike symbol means it is a 0. So the final answer is 2 into x plus y plus z. Then after that, we are going to find del cross effector. It means a curl effector. So curl is always in the form of determinant. I vector, j vector, k vector, dou by dou x, f1, f2, f3. f1, f2, f3 is nothing but the coefficients of I, j, k from the given vector point function. Now we expand this 3 by 3 determinant. So the answer is 0 I vector plus 0 j vector plus 0 k vector. Simply we write it as 0. So it is a curl vector is over. So in the next problem is the same format. Find divergence of effector and curl of effector of the given vector point function at some particular point is given here. The next one is prove that the vector point function is a solenoidal. Already we discussed what is a solenoidal. Del dot effector is 0. It means divergence of effector is 0. We are going to find the given function, vector function f vector. So to prove the given vector is a solenoidal, that is to prove del dot f vector is 0. So to prove this, first we are going to find divergence of f vector. We apply this formula. Then the answer is automatically we getting dou by dou x of z means it is 0 because z is a constant when we differentiate with respect to x, partially with respect to x. So for the second term, so here when we differentiate with respect to y, x is a constant, so it is 0. So the third term, when we differentiating partially with respect to z means here y here, so y is a constant, so it is also 0. The final answer is 0. Therefore, the given vector is solenoidal. So the next problem is using the solenoidal concept, we are going to find the unknown value a. So because this a here occurred here, f vector is equal to here x plus a z into k vector is solenoidal. So here the given condition is f vector is solenoidal. That means we can use this. So that is divergence f vector is 0. That is del dot f vector is 0. So by using this condition, we are going to find this a value. So here dou by dou x of x plus 3y plus dou by dou y of y minus 2z plus dou by dou z of x plus a is equal to 0, which implies a is minus 2. Then the next topic is show that the vector is. It means here write the given a vector point function to prove del cross f vector is 0. So here del cross f means we write it in the, as usual, we write it in the determinant form. We expand this. Then after that the final answer is 0. Therefore the f vector is irrotational. So the next problem is using this irrotational condition concept, we are going to find the three unknowns a, b, c because a, b, c are involved in the given vector point function. So first we write the f vector, then del cross f vector. We expand this. Okay, then after that we write the given condition f vector is irrotational. So we can use this. So del cross f vector means we write this. Already we find I vector c plus 1 under which is equal to right hand side is 0. 0 means we write it as 0i plus 0j plus 0k. So we compare the coefficient of I on both sides, j on both sides and k on both sides. So we're getting a is 4, b is 2, c is minus 1. So we find a4, b2 and c minus 1 using the irrotational concept. Then the next cross problem is if del phi is equal to, so here the gradient phi is given. Using this, we are going to find the scalar potential phi. So del phi is equal to this 2xyzi plus x square zj plus x square yk. So in the left hand side, we substitute I vector dou phi by dou x, j vector dou phi by dou y plus k vector dou phi by dou z. So equating the coefficients of I, j, k, we're getting three functions 1, 2, 3. So we take one by one. So from 1, dou phi by dou x equal to 2xyz. Then after that, here we write a phi term left hand side and is a x term right hand side. Then we taking integrate on both sides. We getting phi 1 is equal to, the function is x squared yz plus some constant, but constant write it as f of y comma z because this integration with respect to x. Similarly, from 2 we can find phi 2 is equal to x squared yz plus some constant. From 3, dou phi by dou z equal to x square y. We are collecting phi term left hand side and z term right hand side. Then integrating on both sides, we are getting phi 3 is equal to x square yz plus f of x comma y. This f of x comma y is a constant. So finally, from 4, 5 and 6, we write 1, 5. That is a scalar potential which is equal to x square yz plus c. I hope everyone understood gradient, divergence and curl and some related topics on these. Thank you.